Equivalent fractions with models. To do this, you first have to start out with two wholes that are equal. So in this case, I'm going to tell you that this circle and this circle, the whole thing, are exactly the same size. Now, clearly have them broken into separate fractions. Here we have fourths. Well, let's say I shaded in 2/4. Now I have 2/4 over here. So I have to look at what do I have to shade on this one to have the same space covered. Because here I'm dealing with halves. Well, I can see it looks like this whole side. So if I just shade in like that, then I have 1/2 shaded, and therefore 2/4. 1, 2 is going to equal just 1/1/2. Because the whole is the same, and we just cut it into different size pieces. Takes 2 of these to equal 1 of those. Same thing down here. You have squares that we'll say are equal. And if I shade in 2/4, it would be the same as shading in 1/2 down here. So 2/4 equals 1/2. A good way for me to remember this is quarters and half dollars. 2 quarters equals 50 cents, which is half a dollar. Let's take a look at some other examples. Say we're dealing with thirds and sixths. As long as my whole is the same, so both of these circles started out the same, and then I cut them into pieces. I have thirds. Say I shade in 2/3. I have to kind of look. Well, it's a little more than half. How many sixths does this take up? A good trick is to kind of think about what this would look like. If I got rid of this line, and this line, and this line, now I have thirds. Well, then what if I just shaded in 2 of them? Okay. Now let's draw those sixth lines back. And so 2/3 would be the same as 1, 2, 3, 4 sixths. So I can write here 2/3 equals 4 sixths. When you're dealing with the same whole, if it's cut into thirds, 2 would be the same amount of space as if it was cut into sixths and you had 4 shaded. Let's look at fourths and eighths. We're going to do the same thing. Say I'm looking at 1/4. So I have 1/4 shaded in. Well, that doesn't mean I'm only going to shade in 1/8. What I need to remember is the eighths, where I could basically just draw a line down. So I can actually do it, and kind of switch it back over. I have fourths, so I'm going to split the fourths into eighths, where I split every 1/4 into 2 equal parts. Now I have 1, 2, 3, 4, 5, 6, 7, 8. Originally this was 1/4. And now I have 2 pieces shaded in. So over here where I had the eighths, I'll have 2. So 1/4 equals 2 eighths. And you can see that they kind of take up the same space. If these pictures were more accurate and completely equal, the fourths and eighths would take up the exact same space. If I picked this up and lay it over top, the amount shaded would match perfectly. Let's take a look at this one. We have sixths, 1, 2, 3, 4, 5, 6, and halves, but our circles are equal. So if I shaded in 3/6 here, 3/6, and now how much? Well, I see that line right up the middle. It's exactly 1/2. So 3/6 equals 1/2. Great. Now let's take a look at this one. Now I have 3/4. And I have it equal to 3/4, but a quick way to find an equivalent fraction is you can oftentimes just split your fraction in half, especially when it's fourths. So 3/4 could equal, if I just draw these lines right down the middle, now I have eighths. Well, how many eighths? 3/4 equals eighths. 1, 2, 3, 4, 5, 6. 6 eighths. So 3/4 equals 6 eighths. Our learning target for this lesson. I can identify equivalent fractions using models. I reposition the shading on this one. You have 2/4 equals, and I have an n over the eighths, I want to know how many eighths. So 2/4 equals how many eighths? You'll have to look at this picture here and think, okay, maybe draw some lines to split the fourths up. How many would you shade over here? And then fill in your numerator for the fraction.